Having already discussed the basic trig functions, we do need to explore the space or possibilities of the inverse trig functions. And just a quick notational comment, the inverse function for sine is typically on calculators called sine to the -1. In this class, we're going to use the terminology arcsine. And the reason for that is when you're talking about derivatives, having things that look like exponents when they're not, this is an inverse notation, but it looks like a power, and then it often leads to confusion when it comes to derivatives. So we're going to use exclusively the terminology arcsine, but just remember it's the same as the sine to the -1 that you see on your calculator. All right. Just to remind you, remember that if we're talking about the graph of sine of x and its inverse, it helps to have a quick sketch of what those graphs look like. I'm just going to add a little 45-degree line here for my own benefit. And remember that sine of x has slope 1 initially and then goes back down, and has slope 1 initially and then goes back down like so. That would be the graph of sine of x, where that's 1, that's -1, and this would be, oops, let's sketch it up there a bit. That would be pi over 2. What does the graph of inverse sine of x look like? Well, it's the reflection of this function across the y equals x line. So inverses replace the roles of x and y, and so the graphs of the inverses are reflections. And so this graph would look an awful lot like this, to about there. Oops. So it would look like that. And then it would look like this. Now at some point, that's probably a little more like that. When we reach 1, there's going to be a little problem that occurs at pi over 2 on this axis. And that's that the function becomes non-invertible. If you remember the horizontal line test, once we cross the sine graph twice with the same horizontal line, we can't go from the y value back to a single x value. So what we do to get around that in practice with the sine functions, where we do want an inverse, even if it's not perfect, is that we cut off the domain so that we can get an inverse function. Most of you have seen this before. It's not a huge deal in this course, but it's worth, if you're unfamiliar with this, it's worth reading up on it in the textbook or online. Just a quick restatement of that. If we look at the domain of arcsine, if you think of that first oscillation for the sine graph, what does it do? It goes from minus pi over 2 to pi over 2, and -1 to 1 in the vertical side. This is sine of x. The translation, when we scope that out as inverse sine, it has that reflected shape, like so, and the range and the domain are exchanged. So we go from -1 to 1 on this axis, and negative pi over 2 to pi over 2 on this axis. So the domain of arcsine or inverse sine of x are all the possible values in here, -1 to 1, or -1 to 1 inclusive in interval notation. And the range, the possible outputs, it's worth putting a full circle at the end here, is negative pi over 2 to pi over 2, simply from the boundaries of this graph. One last comment. Remember that sine takes an angle and gives a ratio. Inverse sine takes a ratio, so a ratio between -1 and 1, and gives back an angle. That's another way to keep the domain and range straight, as if you can remember what sine does, angles to ratios. Inverse sine, arcsine, will take ratios to angles.